In this video, we are going to talk about some interpretations of the line integral of a vector field along a curve and look at some common questions. So the line integral of a vector field along some curve C is the integral of what I can think of as the tangential component of f along C. So, I see this in the representation, how it's written down. We're taking the dot product of f with that unit tangent vector. That is what's called the tangential component of f along the curve. And this measures the extent to which f, my vector field, is going in the direction of C. So if the vector field is generally pointing the same direction as our curve, whichever way we're traveling along the curve, I expect this line integral to be positive. If the vector field is kind of pointing the opposite direction as whatever my curve is, if it's going against the grain, I'd expect it to be negative. Okay, so some terminology. We've mostly been looking at the case where my vector field is a force vector field. In that case, this line integral gives us the work done by the force along C. But if my vector field is what's called a velocity vector field, then this line integral of f dot dr, this is just notation for the line integral, this gives what's called the flow of f along the curve. And in the special case where C is what's called a closed curve, which means it starts and then we travel along the curve, and it ends at the same spot. I'll draw some arrows for the direction of motion. Then the flow has an even more special name. It's what's called the circulation around the curve. And in that case, we can denote the integral with a little circle drawn in the middle of it. That indicates it's around a closed curve like this. We'll see that notation much more towards the ending couple weeks of our class. Okay, so let's look at some common questions. If we change the direction of our parameterization, will the line integral of my vector field change? So if I have some curve connecting 2 points and I travel in one direction, I'll put an arrow in that direction along the curve, versus if I go in the opposite direction. So I'm going to call the opposite direction negative C, and the first direction, I'll call it just C. Will the value change? So it turns out, yes, it will change. In fact, we talked about this with an example in the last video. They end up being exactly opposites. So the line integral in this reverse direction equals the negative of the line integral in the first direction. And the next question is, if we change our path between the 2 points, will the value of the line integral change? Well, so if I have 2 points, and I take one path, and I'm going to call this one C1, and then I take some other path, I'll put it in a different color. I take some other path, and I call this one C2. Well, the line integral of our vector field along the first path and the line integral of the vector field along the second path, well, they may or may not be the same. I'll put a little box and I'll put a question mark. The answer to this is it depends. It depends. We'll explore this more in section 16.3. There are certain special vector fields where no matter what path we take between the 2 points, we'll always get the same thing. And we'll explore that in the next section. But in general, for a lot of vector fields out there, the path between the points matters very much. And changing the path can give us different values. In fact, we saw an example of that in the previous video. We had a vector field, we took 2 different paths from a starting point to the same ending point, and we got 2 different values.